So, you've got all the kit, but before you perform a survey, set up the SC11 system to perform a self-test. This is to make sure that all the sensors are connected properly and are working before used to make an accurate survey of an environment. This is the test area. We've exposed the concrete floor because later on, when we put down accelerometers, they will need to be in contact with it. First of all, attach the two DC sensors. Put them next to each other and facing in the same direction so that they measure the same magnetic fields. The self-test checks for discrepancies between the two readings of the DC sensors. Then attach the three accelerometers. Use the self-test template to put the accelerometers end down in the correct positions. Make sure that they have direct and clean contact with the floor. Also, handle these carefully, for they are very sensitive. The self-test checks that the sensors measure the same floor vibration. Also connect the accelerometers. Once again, make sure they are put into the correct colour-coded port. Plug in the microphone. This has an internal mechanism to make sure that it is functioning correctly. Now it's time to power up the SC11 SI and connect the sensor interface into the laptop with the cables provided. We're ready to start the self-test. So now it's time to perform the self-test. Find and open the survey program. This program enables you to make automated measurements of magnetic, acoustic and vibration signals. On the Start tab, you will see a step-by-step guide to performing a survey. Click Next to bring up the Sensors tab. Here select which sensors are being used. Make sure that the serial numbers on the window correspond to the serial numbers located on the sensor interface and the sensors attached. Make sure that the serial numbers for the DC sensors are correct. For example, here the DC sensor marked with the white colour band is plugged into the MAG1 port, and its serial number matches the serial number for the 3-axis magnetic sensor 1 on the program window. Make sure that the serial numbers for the accelerometers are correct. For example, here the X-axis accelerometer marked with the red spot is plugged into the VIB1 port, and its serial number matches the serial number for the vibration 1 on the program window. With the sensors connected matching the sensors selected on the Sensors tab, move forward onto the next tab. Click the Self-Test Macro button to perform the macro running the self-test. Here you see the macro running different programs that are part of the analysis system software to take readings from the sensors. The self-test survey runs for roughly 2 minutes, but here you'll see the self-test being speeded up. The result window gives a summary of the tests that the macro ran on the sensors. A report is created with each self-test. This report contains more detailed data with graphs of the readings that were made. Clicking this icon leads us to the report. If the test passes, move on to the next tab. If not, the report will help you identify why the self-test failed. Here's a self-test that I performed earlier. Here the report shows that the vibration on the x-axis is much reduced than the y and z axis. This would indicate that the sensor was unplugged, therefore making it quite simple to solve.